In the winter of 2016, in a hospital in San Diego, a 68-year-old scientist named Tom Patterson was dying, and the antibiotics had stopped working one after another until his doctors had nothing left to try. He had picked up an infection on holiday in Egypt, a bacterium called Acinetobacter baumannii, one of the most drug-resistant organisms medicine has ever catalogued. By the time he reached California, he was in a coma, his organs failing one by one, and the most powerful drugs on Earth, the last resort ones kept in reserve for exactly this, did nothing. Everything 80 years of modern medicine had built was useless against the thing inside him. So his wife went looking for an older weapon, one the West had thrown away. What she found was a cure that had been declared obsolete before the Second World War. Kept alive for 90 years in a single crumbling institute in a city most people watching this could not find on a map. A cure whose own government had tried to erase it by taking the man who built it out and shooting him. This is the story of the medicine we buried, the scientist we executed for keeping it, and a question now hanging over every hospital on the planet. What happens when the cure we replaced it with stops working? To understand what saved Tom Patterson, you have to go back almost exactly 100 years, to a laboratory in Paris. In 1917, a self-taught microbiologist named Félix Derel, no formal degree, no salary, working on the margins of the Pasteur Institute, noticed something strange in samples from soldiers sick with dysentery. Something in the filtered fluid was killing the bacteria. Not a chemical, something that multiplied. He grew a culture of dysentery bacteria, added a single drop, and watched overnight as the cloudy broth turned clear. Every bacterium dead by morning. He had found a virus that hunts bacteria. He called it a bacteriophage, an eater of bacteria. And it behaved like nothing else in medicine. Each phage is a specialist. It infects one species of bacterium and ignores everything else, your own cells untouched, your other microbes untouched. It locks onto its target, injects its genetic code, turns the bacterium into a factory for copies of itself, and bursts it open from the inside. Then those copies go hunting. A phage breeds at the site of the infection, multiplying for exactly as long as there are bacteria to feed on, and fading away when they are gone. In the 1920s, this was the only thing resembling a cure for a bacterial infection anywhere in the world. Penicillin was still 2 decades away. Blood poisoning, dysentery, cholera, a wound that turned. There was nothing for any of it. Nothing, except maybe a vial of the right phage. The trouble was finding the right one. And the man who would build the place that could was about to meet Derel in Paris. His name was George Eliava, a Georgian born in 1892 in the town of Sashkir, trained in medicine across Geneva and Moscow, and by the early 1920s working at that same Pasteur Institute, where he met Derel and caught the same fever for phages. Eliava saw what the West would take another 80 years to see, that this strange living medicine could be the future of fighting infection, and he wanted to build it at home. In 1923, in Tbilisi, the capital of Soviet Georgia, he founded an institute dedicated entirely to bacteriophages, isolating them, cataloging them, growing them by the liter and turning them into medicine. It became the largest center of its kind on Earth. And Derel came to him. The two men dreamed of turning Tbilisi into the world capital of phage research. In 1934, Joseph Stalin himself invited Derel to the institute. He accepted and worked there on and off for around 18 months. The institute built him a cottage on the grounds. He wrote a book there and dedicated it to Stalin. For a few short years, in a city on the southern edge of the Soviet Empire, 2 scientists were assembling a library of viruses that could cure the infections killing millions of people, and the most powerful man in the country was watching. That attention was about to turn. In the spring of 1937, the secret police came for George Eliava. It was the height of Stalin's Great Terror, the wave of purges and executions that would kill, by most estimates, more than 1 million people across the Soviet Union. Intellectuals, scientists, officers, anyone who stood out. Eliava stood out. He was arrested and branded an enemy of the people. The charges read like fiction: spying on the Red Army, selling secrets to the French, waging secret bacteriological warfare. His wife, a celebrated Georgian opera singer, was arrested alongside him. On the 9th of July 1937, he was executed. He was 45 years old. There is a story, still told in Tbilisi, that Eliava's real crime was personal, that he had fallen for a woman who had also caught the eye of Lavrenti Beria, the secret police boss who ran the purge in Georgia and would rise to become Stalin's most feared enforcer. Historians caution there is no hard evidence for the romance. What is documented is colder than any love triangle. In those years, Beria engineered the arrest of some 30,000 Georgians and the execution of more than 14,000 of them. Eliava was one name on a very long list. After he was shot, his papers and his photographs were destroyed. His name was scrubbed from the record. For 40 years, the man who built the world's first institute for phage therapy was a non-person, erased so completely that his own institute could not say his name aloud. But the purge could not kill the one thing that mattered. The cure outlived the man who made it. The institute survived him. It was kept running through the terror and the war that followed, largely by the people Eliava had trained, among them his deputy, Elena Makashvili, and a staff that was more than 90% women who would carry phage therapy through the rest of the century. And within 5 years, their work was tested in the worst conditions imaginable. In 1942, as the German army closed around Stalingrad, a second killer moved through the rubble: cholera. It was already tearing through the German lines, and a single outbreak inside the packed, starving city could have killed more people than the shelling. Over 1 million soldiers and civilians crushed together, an epidemic about to ignite, and the Soviets had one defense that didn't depend on drugs they had no way to manufacture. The microbiologist they sent was named Zinaida Yermolyeva. The plan was to dose the city with cholera phage, a virus that would hunt the cholera bacterium and nothing else. But the train carrying her supply from Moscow was bombed on the way. So she built a laboratory underground, in the basement of a wrecked building, and grew the phage in the middle of the siege. To get fresh, potent virus, her teams isolated it from the bodies of the dead. Soviet scouts reportedly crossed the German lines to drag back infected corpses to harvest it. At its peak, they were treating 50,000 people a day, the phage mixed into the bread and the water and handed out with the rations. Stalin himself telephoned to ask whether it was safe to keep 1 million people inside that city. In her words, she had already won a victory on her front. The cholera never caught. By the end of the war, the Soviet army was treating its wounded with more than 200,000 liters of phage. While the West was about to forget phages entirely, the Soviet Union had built them into the bloodstream of its medicine, and that divide between the world that kept the cure and the world that threw it away is where this story turns. So why did the West throw it away? The official version is that phage therapy simply didn't work, that it was crude Soviet pseudoscience and antibiotics beat it on the merits. The truth is more uncomfortable than that. Phages did work, but they were difficult in exactly the ways the new drugs were easy. A phage is a specialist. You have to identify the precise bacterium making a person sick, then match it to the precise phage that kills it. Early Western trials in the 1920s and 30s, run before anyone understood that specificity, gave messy and inconsistent results, sometimes miraculous, sometimes useless. And in 1934, American medical authorities issued damning verdicts on the whole approach. Then came penicillin. Mass-produced during the Second World War, antibiotics had every advantage phages lacked. Cheap, shelf-stable, broad-spectrum, one drug that killed dozens of different bacteria at once. A doctor no longer had to know exactly what was wrong. He could prescribe a single pill and watch it work. Against that, a library of fussy, hyper-specific viruses looked like a relic. By around 1945, the West had abandoned phage therapy almost entirely, and then the door closed. The Iron Curtain came down, and the decades of Soviet experience with phages, millions of treatments, mountains of clinical data, was sealed behind a language barrier and a political one. Soviet results were published in Russian, in journals no Western doctor read, and tainted by association with the enemy. The cure worked the entire time. It had simply fallen into a blind spot the size of a continent, kept alive in just one place on Earth, a place that was about to nearly die itself. That place was the Institute in Tbilisi. For decades, it had been one of the largest microbiology centers in the Soviet Union. Around 800 people, producing phage by the ton, shipping vials across the entire Eastern Bloc. Drops and pills and ointments you could buy in any pharmacy from Georgia to the Baltic for almost nothing. Then, in 1991, the Soviet Union collapsed, and Georgia fell into civil war. The money vanished, the power failed, and inside the institute sat the most valuable part of the whole enterprise, the collection. Refrigerated libraries holding thousands of phage strains, gathered and catalogued over 70 years, a genetic archive of viruses matched to the bacteria that plague us, irreplaceable, and dependent on electricity that no longer came. During the blackouts, the staff watched parts of that collection thaw and die. Decades of work rotting in warm refrigerators while the country tore itself apart outside. They did not let it go. It had survived the execution of its founder. It had survived a world war. Now, it survived the death of the country that built it. Its scientists, many of them descended from the women Eliava trained, keeping the fridges cold by whatever means they could find. In 1997, a BBC documentary found them still working in the ruins, and the West remembered, for the first time in half a century, that this place existed. Which is how, in 2016, a desperate scientist in California came to hear a rumor about a cure she had never been taught, one that had been waiting in a Georgian basement the entire time. Her name was Stephanie Strathdy, and the dying man was her husband. Tom Patterson had been in a coma for weeks, his body overrun by a bacterium carrying more than 40 resistance genes, immune even to colistin, the drug doctors reach for when everything else has failed. His physician, Robert Schooley, had told her there was nothing left to try. So Strathdy, an infectious disease scientist herself, went into the medical literature looking for anything at all, and found a handful of papers on a forgotten Soviet therapy. Then a colleague mentioned a friend who had been treated for a superbug in Tbilisi, Georgia. That was the thread. It connected a San Diego intensive care unit to George Eliava's institute, 90 years on. What happened next was a race. Strathdy and Schooley secured emergency approval from the FDA to treat Patterson with bacteriophages, the first time it had been tried against a bloodstream infection like this in the United States. Phage hunters around the world went digging through their collections for viruses that could kill Tom's exact strain. A laboratory at Texas A&M, a US Navy biological research unit, a San Diego biotech firm. They found matches, purified them, and on the 15th of March 2016, began pumping them straight into his bloodstream, with no guarantee that any of it would work. He came out of the coma within days. By June, doctors could find no trace of the bacterium that had been killing him. In August, he went home. Tom Patterson became the first person in the United States cured of a systemic superbug infection by the medicine the West had buried in 1945. The cure George Eliava was shot for had crossed an ocean and 90 years to save a stranger's life, and it arrived just in time to answer a question the whole world is beginning to ask. Because the antibiotics are failing. For 80 years they have been the foundation of modern medicine, the thing that makes surgery, chemotherapy, childbirth, even a scraped knee survivable. And we have used them so heavily in our own bodies and in our livestock that bacteria have done what bacteria always do. They have learned. Strains are emerging now that shrug off every drug we own, including the last resort ones held in reserve. In the United States alone, antibiotic-resistant infections already strike more than 2.8 million people a year and kill at least 35,000. By one widely cited projection, Resistant infections could be killing 10 million people a year worldwide by 2050, more than cancer. We are running out of the cure we chose, and we are turning, slowly, back to the one we abandoned. Phage therapy is in clinical trials again, in America and in Europe. The first major US government-funded trial of intravenous phages began in 2022. The institute in Tbilisi treats patients who fly in from around the world, selling, once again, the cure its founder was killed for. And yet, as of today, no phage therapy has full approval as a marketed drug in the United States. After 100 years, we are still, in effect, starting over, relearning what a Georgian scientist already knew before Stalin had him shot. So here is the question worth sitting with. We had two answers to the deadliest killers in human history. We chose one and buried the other so completely that we had to rediscover it by accident, in a coma ward, 9 decades later. The one we chose is wearing out. The one we buried has been sitting in a basement in Tbilisi the entire time. How many more answers are out there that we have already thrown away? And how long are we going to wait before we go looking? Until the drugs stop working? Or until the last people who remember are gone?